Let's take a faraway voyage into the voids of time, to a place without sadness or despair, and where love will never die. A land without troubles or doom, the place they call the far side of the moon.
The dream of a perfect world will live as long as mankind exists. It's a world without politics and dictatorship, without enmity, hatred, lies, and violence. It's where science exists in the same space, beyond borders and eras. Perhaps this dream of an ideal world was reflected by medieval astronomers who created a map of the moon. The lunar seas were the first to receive names like the Sea of Fertility, the Sea of Nectar and Serenity, the Sea of Tranquility, and the Sea of Rains. Then there was the Lake of Dreams, the Bay of Rainbows. However, the Marsh of Epidemics spoiled the overall picture somewhat, but it was a swamp. All the mountain ranges of the moon, by tradition, established back in the 17th century, were given earthly names: the Alps, the Pyrenees, and the Caucasus. And the craters were named after great scientists, philosophers, and writers. This tradition continues even today. According to the rules of the International Astronomical Union, lunar objects cannot be named after heads of state, military leaders, or religious figures. There is another restriction. The reputation of the person whose name will be immortalized on the moon has to be impeccable. That is why one crater on the far side of the moon received the name of the Russian scientist Alexander Stoletov. At the start of 1893, Russian academicians Chebyshev, Bredikhin, Beketov proposed to elect the foremost physicist and world-famous Russian scientist Alexander Stoletov as a member of the Russian Academy of Sciences. However, the imperial president of the Academy, Grand Duke Konstantin Romanov, used his power to impose a veto on Stoletov's election. It was quite an incredible decision in relation to a scientist of such caliber. Stoletov took as an insult. When his brother Nicholas, a general, a hero of the Battle of Shipka, asked the Grand Duke to explain the reason for his refusal, the Duke replied, "Your brother has an impossible character."
The refusal was unexpected. The achievements of a scientist should be the grounds for admission to the Academy of Scientists. Stoletov had achievements, and they were considerable. But, of course, great things often become more apparent over time. And today, more than 100 years later, we can rightly say that Stoletov was far ahead of his time. His research anticipated the emergence of modern quantum and electron theories. His work enabled the creation of such technological wonders as the television, camera, video camera, X-ray machines, copy-making machines, phototelegraph. Stoletov's photocells work through the night on telescopes, open supermarket doors for us, incorporate actors' voices into film soundtracks, and even switch on the security alarm system. Stoletov's legacy for the 20th century includes all electronics and radio engineering, from the radio to the radar. Of course, the Grand Duke, a poet, playwright, translator, and president of the Academy of Sciences, could never have guessed this. But what if he had known this was going to happen?
Alexander Stoletov graduated from the Faculty of Physics and Mathematics of Moscow University in 1860. After a brilliant graduation, he was offered a job as a lab assistant. This position was created especially for him. However, it took nearly a year to agree to the new position. During this time, Stoletov managed to prepare for his master's degree in physics. But suddenly, he gave up everything and left. He decided to master skills in the art of physical experiment. This requires a good laboratory and, in Russia, there were none. So Stoletov headed for training in Germany.
This was the golden age of German physics. In the 1860s in Germany, a number of outstanding schools were established, not only in one city but several: Göttingen, Berlin, Munich, and Heidelberg, among others. The mid-19th century at the University of Heidelberg is generally considered the time of triumph for natural sciences. This is due to the works of Robert Bunsen, Gustav Kirchhoff, and Hermann Helmholtz. And to this intellectual center there comes the so far little-known Alexander Stoletov from Russia. When we say the outstanding scientific school, it implies not only a teacher, for example Kirchhoff, but also the students, such as Stoletov.
In one of his letters, Kirchhoff wrote about Stoletov as the most talented of his students. Later on, before sending all his works to be published, Kirchhoff gave them to Alexander Stoletov to read.
Actually, in my opinion, he became the first Russian physicist recognized by the European scientific community. They recognized him as an equal. That's the thing. It's very important. It's not enough to do a good job. It's important to have it recognized. It's important that your level is recognized by everyone. But it was not only because he did a good job, but also because he did his work with people like Weber and Kirchhoff, who by that time had already been part of the elite in the European scientific community. From this point of view, it can be said that Stoletov built a bridge to the European world of physics.
In Weber's laboratory, Stoletov learned the art of making experiments, carefully taking all precautions he could. Later on, he would be teaching his students all of these skills. It was here in Weber's laboratory that Stoletov understood that to become a true physicist, you need to combine the talents of a theoretician with experimentation. With that aim, he returned to Moscow University. It then took Stoletov 8 months to prepare for his first series of lectures. Finally, he stepped up to the lectern, a young man, not yet 30, looking like a dandy, wearing a button frock coat. He was energetic, smart, with an almost military countenance.
I'm going to offer you a brief overview of the various divisions of our subject. Until recently, they stood apart from each other, and even now, they are not tightly aligned.
And he told them about mathematical physics, about how closely the two disciplines of physics and mathematics are intertwined. And then he showed them an experiment with two charged spheres.
This is a very simple experiment. Here are two spheres. Both are charged with electricity. They interact with each other. And how do they interact? And right here, mathematics comes to help physics. The spheres interact with each other with a force inversely proportional to the distance squared between them. Using the same mathematical regularity, we can describe the laws of illumination and Kepler's law. This was used by Halley to calculate his comet and the law of universal gravity. That is, we describe the interaction of two small charged spheres in the same way as the interaction between the Sun and the Earth, or the Earth and the Moon.
In autumn 1892, there was a big quarrel between the rector of the university, Bogolepov, and Stoletov, caused by a series of tragic events. A poor harvest led to an increase in food prices, and the university's low-paid employees suffered from the disaster. The rector didn't even give any pay raise to the employees, but also forbade their wives from earning money at the university as laundresses and dishwashers. One of the employees died of starvation. On hearing the bad news, Stoletov proposed to create a commission for assistance and to request the university trustees to increase the salaries of employees. The rector was terribly unhappy that Stoletov went over his head to address the trustees, accusing him of awful behavior and theft of documents from the university office. According to contemporary accounts, he was a tall man, straight as a stick, with a fixed stony look. He got the nickname Stone Guest. The claims were soon found to be false, but Bogolepov refused to apologize. Stoletov no longer shook his hand. Rumors about the conflict at Moscow University came to the president of the Academy of Sciences, the Grand Duke Konstantin Romanov, as well as the governor of Moscow, the Grand Duke Sergei Romanov, whose support Rector Bogolepov enjoyed. This was the point at which Stoletov was due to be made an academician. The Grand Duke vetoed the decision. Alexander Stoletov could not hide his resentment.
I was informed from St. Petersburg that the rumors of my fallout with the rector caused the postponement of my election to the St. Petersburg Academy of Sciences. No matter how you look at this incident, I wouldn't think it so important, and the guilt attributed to me not so hard. To close the doors of the institution where I could have devoted the rest of my life to science. 28 years have already been given to scientific activities. That you can't call unsuccessful.
The first scientific work of Alexander Stoletov was called The General Problem of Electrostatics. For two conductors, this problem was solved by the geometrician Morphy and the great English physicist Lord Kelvin. Stoletov set the goal to find a solution for any number of conductors of any shape. He managed to solve the conundrum in a very simple and elegant way. He worked out the sum of simple interactions between pairs using a complex interaction of a great number of conductors. All Stoletov's subsequent works were remarkable for such elegance, virtuosity, and grace of thought and execution. In 1872, Stoletov defended his doctoral dissertation, The Study of the Function of Magnetization of Soft Iron. This theoretical work had a great practical importance for the development of electrical engineering. Decades later, the method developed by Stoletov was the basis for the study of techniques to study magnetic properties of iron, cast iron, and steels of different grades used to create electromagnetic motors, generators, transformers, and relays. In the same year, as a newly made professor at Moscow University, Alexander Stoletov planned to establish Russia's first educational and research physics laboratory.
It's very simple. When working on his dissertation, Stoletov spent 4 months in Heidelberg in Kirchhoff's laboratory. There, he designed a machine to study magnetic properties of iron. He also conducted all planned experiments. He then had a strong belief that there would be no proper research without a good laboratory. Say I'm going, for example, to a room to conduct an experiment. What do I need? I need possibilities. What instruments and what employees should be in my laboratory? I need a very good workshop for mechanics. I need glass blowers. That's what, of course, Stoletov thought about, drawing from the experience of the best laboratories in the world, available to him in Germany. He wanted to organize a similar one in Russia.
Stoletov was trying to organize such a laboratory for a long time. He spent a lot of effort and money proving the urgent need for new equipment and modern physical devices. But he was told, why do we need new instruments? Those that we have at the university are sufficient.
Yes, sufficient. Here, for example, is a fine piece of magnetic iron ore with an inscription in Church Slavonic. This magnetic stone heaves 2 pounds of weight.
A laboratory is a table with a device on it, and that's it. At that time, when there were no instruments at all, Stoletov instead started to practice physics as a science in Russia. That's the point. This man was in Russia and in Moscow University and created the scientific basis from which to conduct scientific research without teaching. He formed a group of people who became engaged in the task. And the majority of physicists in Russia were brought under Stoletov's supervision.
It took real effort to get it going. Stoletov was aware that to develop physics as a science, an institute was needed, but it seemed a remote prospect. Here, at least, he could try to get a laboratory. He patiently explained to the officials that the magnificent university exhibits were more suitable as historical relics. He wrote letters, petitions, and paid visits, and finally won. He received premises and funding. Part of the equipment was bought in Germany, and some devices were made by Stoletov's laboratory assistant Ivan Usagin, a real Russian talent.
Ivan came from a peasant family in the Klin district, Moscow province. His parents died, and his uncle, a shopkeeper, took charge of his upbringing. Ivan worked as an errand boy, so he transported things, opened and closed doors for visitors, and did other general tasks. So that was his job. The boy learned how to read and visited different book markets, which he could find in Moscow. And at some point, Ivan began to read books on physics.
The boy reading physics drew attention, but it was hard for him to convince his uncle to let him go to university. The decisive factor was Professor Lubima's visit in a smart uniform with all his regalia. His uncle sighed and gave in. As a result, science received an industrial transformer, which was later invented by Ivan Usagin. And Alexander Stoletov got a wonderful laboratory assistant and a friend of many years. Each lecture required careful preparation. Before dawn, they arrived at the lecture hall to check everything. Each time they prepared as if it were for an exam, where Stoletov would strictly examine his students.
A student must be prepared for the exam. This is the first rule. Secondly, he didn't like those who just memorized text without understanding it. He was very fond of witty and clever students who could find some way out of a difficult situation. For example, when he asked, "Under which circumstances can a flea not jump?" some students became confused so that they couldn't answer. And that's the point. Such a question knocked them out. But some were ingenious and answered that the flea could not jump from a completely smooth surface.
They had to figure out there's no friction on an absolutely smooth surface, and a flea has nothing to grasp onto, and that's why it can't jump. The sharpest students received the highest scores. Slackers were not spared. That's how he educated. And when one of his students fell ill with pneumonia, Stoletov spent 2 weeks by his bedside until the young man felt better. For many students, he was their favorite professor. But with colleagues, he often had arguments.
Alexander Stoletov had a rare gift to gather talented people around him. He had a rare gift to quarrel with everyone on any occasion. Not all, only with officials. He was a very balanced person. Troublesome and quarrelsome. How do you know that? The head of scandals, Stoletov. Stories of the faculty, caused by Stoletov, turned into a continuous story without beginning or end. From the troublemaker, Stoletov, professors ran away in panic, and the dean, Bugaev, showed miracles of dexterity to save his position. Those are the memories of Andrei Bely. Bely wrote down these memories from his father Bugaev, who was dean of the physics and mathematics faculty, a troublemaker who despised Stoletov and called him a poor merchant. It's a contemporary view. It's envy.
In the spring of 1893, there was the so-called Golitsyn history. Duke Boris Golitsyn, eventually one of Russia's most famous Russian physicists and a founder of a new branch of science, seismology. He was working in Stoletov's laboratory on his master's dissertation called Studies on Mathematical Physics. Stoletov was his reviewer and was doubtful about Golitsyn's main conclusion about the temperature of the radiant energy. Just 10 years later, this provision would be included in physics, but in those days, it was considered possible to apply the concept of temperature only in relation to the substance. Duke Golitsyn refused to make changes in his dissertation. Stoletov said he would give him a negative review. In other circumstances, it would have been an ordinary situation. But Golitsyn's patron, Grand Duke Konstantin Romanov, was president of the Academy and learned about the trouble the dissertation's author was facing. Defense took place on April 14th. The meeting of the Academic Council was in contradiction to the general rules. The trustee of the school district, Count Kapnist, took the chair instead of the dean of physics and mathematics. This went against the rule of proceedings. The professor of mathematics, Nekrasov, was appointed attorney of law for Duke Golitsyn. The meeting was also attended by Rector Bogolepov, law professor. Stoletov, as a reviewer, was not allowed to take the floor. First, Nekrasov gave a speech heavily criticizing Stoletov. Then the candidate for the decree, Golitsyn, read the response to Stoletov's review, which was a violation of all the rules. After that, Nekrasov took the floor again and offered to consider Stoletov's conclusion invalid. Professor Timirazov became indignant and said, "Never before in this faculty, since I had the honor to be present at its meetings, has there been such a humiliation." Some university professors, such as Sokolov, Menzbir, Lyubavin, were also against Nekrasov's suggestion. In the end, the defense of the dissertation was postponed till autumn. But they made it clear to Stoletov that his election to the Academy depended on whether Duke Golitsyn would get his master's degree. And in late April, Academician Wild sent Stoletov a letter advising that he withdraw his consent for voting. He wrote that the Academy of Sciences had already received a lot of attacks about Stoletov and that he would obviously fail in the elections. Alexander Stoletov replied,
Highly respected colleague, the fact that members of the Commission, people like Bilstein, Birketov, Bredichin, Chebyshev, spoke so strongly and so unanimously in favor of me was and still is a great honor for me. I'm afraid that the voluntary renunciation of my candidacy could seem rude and ungrateful towards the worthiest people who wish to see me in their midst. Also, I have to admit that from the whole story my head is spinning. Perhaps it's a consequence of a nervous state in which I've found myself for the last few months. So I prefer to let the matter take its natural course.
How all this trouble interfered with his work. For 6 years, Alexander Stoletov studied the photoelectric effect and was nominated to the Academy for the results he achieved. Day and night, as a single man, he worked in a small office next to the physics laboratory. He was interested in the phenomena studied by various disciplines separately. Stoletov thought that nature was a single whole and everything was interconnected. Physics and chemistry, electrics and magnetism, mechanical work and heat. It was found that under light, electric current could be generated, and this phenomenon was called the photo effect.
Stoletov is associated with the discovery of the photo effect, but he was engaged in the external photo effect. The phenomenon was originally discovered by Hertz when studying electromagnetic waves. Stoletov, intrigued by this phenomenon, began to develop it further, and he actually discovered the laws of the photoelectric effect, which formed the basis for creating photocells.
The photo effect is an emission of electrons by a substance. When exposed to light, the theoretical basis for this phenomenon would be given by Albert Einstein only in 1907. And for his quantum theory of the photo effect, he would receive the Nobel Prize in 1921. But the first step was taken by Stoletov in a tiny office on a self-made device built by Ivan Usagin. The zinc plate fixed on the glass stem for insulation is the cathode. The metal grid is an anode, which Stoletov himself called the grid capacitor, which is placed in front of the plate. The cathode is connected to the electroscope. The anode is connected sequentially with the galvanometer to the battery. If you send a beam of light to the cathode, then it immediately discharges. The cloud of ejected electrons is attracted to the positively charged grid, and the galvanometer registers the presence of a current. The most mysterious part of the story is that the light pulled the electrons from the plate immediately. It contradicted the existing wave theory of light, popular at that time. Stoletov found another mystery of the photo effect, the existence of a threshold. The current arises only when the wavelength of light is short enough, and that threshold is different for various substances. For example, zinc reacted only to a very short wave, ultraviolet light. And with the other metals, a longer wavelength, blue or green, was used to pull out the electrons. But electrons almost didn't react to infrared or even red light. Increasing the intensity of the long wave light illumination did not give any results either. From the viewpoint of the wave theory, it was inexplicable. Intense light, regardless of its wavelength, would have worked better. Created by Stoletov, this method of studying electrical phenomena in rarefied gases using the galvanometer served as the basis for the work of Marie and Pierre Curie and helped discover radium and polonium.
Stoletov couldn't explain the phenomena of the photo effect he observed with contradictions of theories and experiments existing at the time. However, his further research had enormous consequences. They led to the introduction of the corpuscular theory of light and quantum physics. The study of the phenomena of the photo effect brought Alexander Stoletov worldwide fame. In Paris, he took part in the Second International Electrotechnical Congress, where he was elected Vice President of the Congress. In France, he was awarded with the Order of the Legion of Honor with the motto, Honor and Fatherland.
In autumn 1893, discussion of Golitsyn's dissertation did not resume. And in late October, Stoletov found out that the Grand Duke personally crossed out his name from the list of candidates for members of the Academy. It's such savagery, isn't it, that you cannot even dream of, Stoletov wrote to his friend, Professor Vladimir Mikhailson. Alexander Stoletov was deeply upset by this injustice. His colleagues, friends, and many European scientists tried to comfort and encourage him.
What you told me in your last letter did not impress me at all. Mendeleev was once blackballed. I would be consoled by the fact that the best modern Russian scientists, Mendeleev, Mechnikov, are not in this almshouse. Being in their company is a shame. Professor Shvedov. Highly respected colleague, I feel high respect both in relation to your outstanding scientific works, as well as the personal qualities of your character. I ask you to openly show this letter to anyone you wish so that they could see my willingness to stand up for both points as I have enough authority. Yours sincerely, Ludwig Boltzmann.
They came around to show their support at his house, a large professor's apartment. Previously, it was always full of people. Before the training laboratory opened, Stoletov students came here for lessons of the physics circle. He could very plainly and clearly talk about complex physical processes. He had enjoyed showing simple physical experiments since childhood. That was a tradition of the Stoletov family.
In the evening, the family gathered in the living room to have tea. When the tea was over, everyone found something to do. Someone was reading a newspaper, someone was looking through an album, someone was doing embroidery. Stoletov sometimes made experiments. For example, the tiled radiator was heated in the winter, and when it was touched with a piece of old newsprint rubbed with a brush, a miracle happened. The sheet of paper stuck to the radiator. The family gasped with surprise. Mama was delighted, and so were the younger brother and sister.
Moreover, Stoletov's apartment was famous for its musical soirees. A close friend of Alexander Stoletov was the composer Sergei Taneyev. Sometimes he accompanied on the piano, while the well-known chemist Vladimir Markovnikov and the famous astronomer Fyodor Bredikhin sang. But he most often played the piano. Stoletov's apartment was jokingly called Scientific and Cultural Center of the university. For example, Stoletov's meeting with the composer Taneyev happened under amusing and curious circumstances.
They say that it became fashionable to ride a bike. It was allowed to do it near the Alexander Garden till 9 a.m. One day, Stoletov was riding down the alley, and someone was riding towards him. Perhaps they both gazed in different directions, so they crashed into each other. Being polite people, they both stood up and bowed, apologizing to each other. So the meeting of the outstanding composer and not less distinguished professor of physics happened in such a way.
Moreover, they were fellow countrymen. Both men came from Vladimir. They spent hours remembering what was close and dear to them both. Alexander Stoletov read notes from the childhood diary.
The aunt had a garden, huge, shady, and full of all sorts of flowers and trees and decorated with statues. One of the statues was a monk on the threshold of his cell. It was surrounded by trees. The garden was located on a hill, so the statue was visible from some places of the embankment. They say one lady who saw the monk from the street asked him how to get to a certain lane, but received no reply. She waved her hands and said, leaving, "That's what you're like. You can't even say a word."
At the end of the ill-fated 1893, Alexander Stoletov was invited to take part in organizing the 9th Congress of Naturalists and Physicians. But it was not without scandal. Professor Nekrasov, who had been Duke Golitsyn's attorney at law, began to praise the advantages of Rector Nikolai Bogolepov at the meeting of the Committee on Preparation of the Congress. Stoletov became indignant and left. Nekrasov demanded they should show disapproval of Stoletov on the grounds that by hurting the rector's honor, he hurt the honor of the university. And then he sent a written denunciation of Stoletov to the Minister of Education, Count Delyanov. Delyanov looked into the case so that criticism of the rector was treated as incitement of students to riot. It looked like a strange case of deliberate persecution of the scientist, as though he were being avenged for sticking to his principles. During numerous student riots, Stoletov always caused scandals, because he always took the side of the students. Then he was often found to be an instigator of all trouble and squabbles.
As Clement Timiryazev's son said, he retold his father's story. In a professor's room, the well-known lawyer, Count Komarovsky, said that soon there wouldn't be any student strikes at the university because there wouldn't be such people as they would be kicked out. He pointed at Alexander Stoletov.
Alexander Stoletov was unable to cope with the endless stream of slander and insults. He suddenly wanted to go back home to Vladimir. When his mother was alive, who he loved more than anyone else in the world, Stoletov came to the family home every Easter holidays. They kept a note of his father, Merchant Gregory Stoletov, in the calendar for 1839, the 29th of July, at 11 p.m. my son Alexander was born. There in the walls, his mother hung embroidery that he made as a child with his sister Varinka. There the teacher Ivan Sokolov walked with them as children around the ancient city and showed amazingly beautiful churches, recalling their names. He told the story of each cathedral and thus the history of the fatherland. Life there was filled with warmth and love, with comfort now gone from his life forever. Stoletov's hair suddenly turned gray. He got old and haggard. He stopped going to theaters and concerts, to the meetings of the faculty and the scientific societies. Having been sociable before, he suddenly became closed, nervous, and irritable. He started to feel unwell. Diseases clung to him one by one. In May 1896, he came down with pneumonia.
Stoletov died overnight, from the 14th to the 15th of May 1896. He died so quietly that his sister Varvara, sitting next to him, decided that he'd fallen asleep. And Moscow that night was roaring, singing, dancing, drinking, having fun on the occasion of Nicholas II's coronation. The death of the first Russian physicist Alexander Stoletov was not even noticed. In early morning of the 18th of May, the coffin with Stoletov was taken to the Nizhny Novgorod train station to bury him in Vladimir, according to his will. The professor was going home. At the same time, there was a national catastrophe, as scores of people were killed in a serious crowd accident in Hrdinka. The hearse was slowly going through the festive streets of Moscow. Stoletov was being seen off by close friends, Timoryazov, Lebedev, Zhukovsky, and even students and the university's gateman. This gateman later said, "If we had not gone to the funeral, how many of us would now be lying at Hrdinka?"
Alexander Stoletov was buried in Vladimir next to his parents and brother. Many years would pass before he would be spoken of as the first physicist in Russia. In 1953, in front of the physics department of Moscow State University on Vorobyovy Gory, a monument was established to the founder of the Russian School of Physics. Vladimir University, 2 streets in Moscow and Vladimir, an avenue in Volgograd, and a crater on the far side of the moon would be named after Alexander Stoletov.
So we were celebrating Uncle Vanya's birthday. Me, Varenka, Mummy, Daddy, and Metya were there. Aunt Masha with her husband and father were also there. We had watermelon, 2 types of apple, 6 sorts of jam, and other food. Sausage, herring, caviar, pie, ham, roast goose, and sweet meringue pie.
Concept and narration, Yaroslav Narcissov. Scriptwriter, Marina Sobepanek. Director, Sergei Vinogradov. Translation and voiceovers by Alexei Bashko, James Brown, Michael Kravchenko, Yelena Sears, Richard Sears, Anastasia Trofimova, Natalia Vdovichenko, David Watson, and George Watts. The film was created with financial support from the Medical Research and Production Complex Biotics and the Scientific Research Institute of Cytochemistry and Molecular Pharmacology.